Good day all. In this session, we are going to discuss about the projection of solids, which falls under the third unit of engineering graphics. Actually, in order to understand and remember the various solids, first we have to understand how it is classified. So here I have classified the solids into two major groups. One is group A and another one is the group B. In the case of group A, we have taken the solids which have the top and base of same shape. See, for example, okay, for say for example, if you take a cylindrical shape, the base will also be a circle and the top will also be a circle. Now we can see some examples for this also. In the case of cylinders here, you can see. So here this base is also a circular shape as well as the top is a circular shape. And this falls under the group A. And another kind is called as the prism. And in the prisms also you can see in both the top as well as in the base, you have the similar shapes. So here you have the pentagon in the top as well as the pentagon in the base. Similarly here the top and the base we have the hexagonal shapes. These are the category which falls under prisms. Okay, so according to the shape of the base or top, we are classifying it as triangular prism, a square prism, pentagonal, hexagonal, etc. And the case of cube, so here all six sides are same, that is similar shape and size. So we can also call it as a square prism. And since all the four lateral surfaces are also of same dimension, we call it as the cube. And since the six equal faces are present, we call it as hexahedron also. It will also be called as hexahedron. So if you go for the group B, so the solids will have some shape in the base, and the surfaces which emerge from the base, they join at the top as a single point, and that particular point is called as the apex or vertex. So here in the cone, we have the circular shape at the base, and the surfaces which emerge from the circular base, they join at a single point at the top, and this point is called as the apex. In the case of pyramids, it's also called as the vertex. So if you take the triangular pyramid or square pyramid or pentagonal or hexagonal pyramid, so here you can see this is a triangular face, and from each side of this triangular base, one triangular surface will be emerging, and all these surfaces will be meeting at a common point. Here, this is called as sometimes called as the vertex and sometimes called as the apex. And the tetrahedron means it has four shapes which are similar or same. So in the case of cube, which we called as the hexahedron, there are six faces, and all the six faces have the same shape as well as the dimension. Similarly, in the tetrahedron, four faces will be there, and each face will be a triangular shape of same dimension and the same shape. Okay, so this is the tetrahedron. This is the brief classification of the solids. Now we can discuss about the dimensional parameters of different solids. See, in the case of a square prism, a square pyramid, cylinder, and cone, we have taken four different solids as an example. So here, these are the four solids as we discussed in the previous slide. Okay, the first one here we have the top and as well as the base with the same shape. That's a square shape. And since these are connected by the rectangular faces, we call it as the square prism. And in the case of square pyramid, here the base is the square shape and the triangular faces are emerging from each surface. Okay, and here we call it as the what you say that square pyramid. And in the case of the cylinder, the top and the base are of circular shapes and they are connected by the circular or the lateral surface. And in the case of cone, here it is the base is a circular shape and they join at the top point called as the apex. Okay, fine. So here we are going to see the different parameters. So this face, that is which is present at the top of the prism, this is called as the top side. And here we can see the rectangular face. That is, in the top we are having a square, and in the bottom we are having a square. The two square edges in the top as well as the base, they are connected by a rectangular face. This is also called as sometimes lateral surface or the rectangular surface. And the line which joins the base corner with the top corner, This line is called as the lateral edge or longer edge. See, these base corners are joined with some edges called as the base edges or shorter edges. Whereas if the base corner at the top and the base corner at the bottom, if they are joined together, then we call it as the longer edge or the lateral edge. And as we just discussed now, this is the base corner of base. And this is the edge of base or side of base. And this side is the base. So this is the base. And similarly, in the pyramids and cones, that is which falls under the group B, we told that the top, all the surfaces will join at a point called as the apex, or we can also call it as the text here. And the line which joins the apex with the base corner, okay, this line is called as the slant edge. Here it is a straight line, okay, it's a straight edge, it's a longer edge, but here it is a slanting line, this is called as the slant edge. And this is the base of the pyramid. And this is the edge of base or side of the base. And this is the corner of the base, that is for the square, this is the base. And here this surface, so here we told no, the rectangular face which joins the edge of the top with the edge of the base. Here we have the edge at only base, and at the top it is just a point. So here we will get a triangular surface. Okay, this is called as the triangular surface. And in the case of cylinder or cone, we do not have any specified or visible edges like in the prisms or pyramid, because here we will be having a curved surface. And in the curved surface, you can imagine n number of lines. Okay, these lines are also called as the generators. Okay, these lines are called as the generators. So here we can see these are the generators. These are the imaginary lines which generates the curved surface of the cylinder as well as the cone. And here this is the base of the cylinder, and here this is the apex of the cone, and this is the base of the cone. Normally, if we say the height of the solid means, here we will be considering an imaginary line called as the axis line, which passes through the centroid of the base. Okay, so in that centroid line, it is called as the axis. And here, if the cone, okay, if the cone is cut by some sectional plane in an inclined manner like this, if it is cut by a sectional plane in an inclined manner, so this will be the shape, no? The top portion will be removed and the base portion will be retained. This is called as the truncated solid or the truncated cone. Similarly, if you imagine this cylinder, which is cut by a section plane, an inclined cutting plane, so this kind of shape will be obtained. This is the truncated, the pyramid. Okay, so these are the sections of solids, that is the top and base are not parallel here because the parallel portion is cut and removed out here, and here anyhow they are not parallel and the part of the portion is removed. And this is called as the frustum. Suppose the same cutting edge, if it is a straight line, a horizontal line, okay, then in the top also we will be getting the similar shape to the of the base, but the size of this particular polygon will be smaller than this one. So here it is a bigger square and here we will be having a smaller square. This is called as the frustum. So here in the case of cone also you can obtain. If you cut with a horizontal line, then in the top face also you will be having a circular portion. The base will also be a circular portion, but the size of circle in the top is somewhat small when you compare to the base. So this is called as the frustum of cone and pyramid. Actually, this is frustum of pyramid and cone. The top and the base are parallel to each other. So these are the different dimensional parameters of the solid. So here we will be discussing only with respect to the first angle projection. So in the case of first angle projection, so this is the reference line. And so what happens if the solid is standing on its base, then the front portion, if it is a pyramid or cone, the front view will be a triangular shape as shown here. Okay, the front view will be a triangular shape which is shown in the figure here. Okay, so this is one that is which is standing, okay, which is standing on its base on the horizontal plane, or sometimes we can call it as the ground also. Okay, and here see the axis in this case is perpendicular to the horizontal plane. The axis is perpendicular to the horizontal plane and it is parallel to the vertical plane. This is the front view of the cone. Okay, of the pyramid or cone, whatever it may be. And in this case, what we have done, this axis is parallel to VP. But what happened? This is now at some inclination with respect to the horizontal plane. And also what happens, see, one point of the base is now resting on the horizontal plane. Okay, one point of the base circle. So since it is base circle, we can take this example for cone. One base point is resting on the horizontal plane, and then here the axis is inclined to the horizontal plane. If you produce it, okay, if you produce it, we can get some inclination with respect to the vertical horizontal plane, and the axis is parallel to vertical plane. And if in this position, see, this triangular face or this generator is made to completely lie on the reference line. That is a HP. So lying on HP on one of its generator, and here the axis is again parallel to the vertical plane, but inclined to the horizontal plane. So based on this, we can draw the positions of the solid. Based on the data given in the question with respect to the axis, we can draw the different positions of the solid. Okay, and in the same case, suppose if the object, okay, if the object is resting on the vertical plane on its base, actually we cannot say it is standing. It won't be an appropriate word because the solid cannot stand on VP. Either we can say it is resting on VP, and here we can say that the base of this particular pyramid is resting on the vertical plane, and here the axis, okay, the axis is parallel to the vertical plane, and it is it is parallel to the horizontal plane, and here it is 1 second. Okay, it's parallel to the horizontal plane and is perpendicular to the vertical plane. Okay, in this case the axis is parallel to the horizontal plane and perpendicular to the vertical plane. And see the next case. So here one of the base point is resting on the vertical plane. The axis is still parallel to the horizontal plane, but it is inclined to the vertical plane. If you produce the axis to the reference line, we can say it is we can observe some angle made by the axis. It is resting on the vertical plane on one of its base point, and the axis is parallel to VP, parallel to HP and inclined to the vertical plane. And in this case, the generator is completely resting on the vertical plane, and here also the axis is inclined to VP and parallel to the HP. So these are the different positions of the solid. So we in this session we have discussed about the different types of solids, the different parts of the solid, how to call, and what will be the different positions with respect to the horizontal and the vertical plane. In the next video, we shall discuss the remaining things. Okay, thank you all.